Good evening, mga kasama at mga ka-automation. Tonight, I would like to share sluice gate automation. Sluice gate are built at the river confluence or dam aqueduct where flow needs to divert from or to the mainstream. Purpose is to divert flow to an aqueduct for the purpose of water treatment, to divert flow for irrigation, to prevent flooding. So these are the purposes of sluice gate. The method of control, normally for dams and for big sluice gate, is using local control via push button or HMI. Okay, and always unnecessary most of the time in today's industry 4.0 is remote control via SCADA using this supervisory control and data acquisition. The required integrated instruments is number one is flow meter. We need to know the flow rate to the aqueduct or to an open channel if it is in a dam. So gate position encoder to know the position of the gate at any time. Limit switches for the gate to prevent the over travel. And torque switch also is very important to prevent damage to the gate or to the shaft that drives the gate. Of course, better to have a PLC, SCADA PC, HMI, local panel suitable for remote control and motor monitoring. Okay, how to measure the flow in a sluice gate application? So we can apply this formula using conservation of energy from Bernoulli's principle. Q equals B, Y1 times Y3 times the quantity inside this 2G over Y1, Y3 raised to 1/2. Where Y1 is upstream flow depth. This is the gate. Y3 downstream flow depth. Y2 gate opening. B is the plume width, the width of your channel or aqueduct. Q is flow rate and G is gravitational acceleration. So the flow rate is Q equals B, the plume, Y1 times Y3 times this quantity. This is 2G Y1 plus Y3 raised to 1. We can also express the formula for flow rate using the contraction ratio and the discharge ratio. For the contraction ratios, you see, it is Y3 over Y2. So we can actually solve the flow rate based on the opening Y2. So we solve for contraction ratio. Then we solve for the discharge coefficient or discharge ratio, which is CC over 1 plus C times Y2 over Y1 times the raised to 1/2. Okay, and we can arrive at the formula of flow rate is B times the discharge coefficient times Y2 is the opening of the gate times 2G Y1 raised to 1/2. Then how can we measure Y3, Y1? Of course, Y2 we can measure by determining the opening of the gate by position encoder. We can measure Y1 and Y3 using ultrasonic sensor. For example, this is your channel, open channel. You can use an ultrasonic sensor. So there are a lot of ways to measure the flow rate. First is you measure the depth and compute, do the calculation. Also, you can measure the velocity, using also ultrasonic sensor. There's no direct measurement of flow rate. First, we measure. The only way to measure flow rate is measuring velocity or measuring pressure difference or head. Okay, so this is an example application, I have 3 gates in my HMI or in my SCADA, 3 gates. And I have sluice gate 1, sluice gate 2, sluice gate 3. Then the opening is being determined by this valve opening. This is in hashtag because we are not really connected to an actual sluice gate. This is just a simulation from my Siemens. No? You have an open, close, stop. Then you can also do some modulation. No? Modulate, you can put the set point so that the valve will open at the desired modulated set point. Okay. Then you can go to test jog the sluice gate. So this is designed to operate remotely because when there's a flood, we need water downstream for the use of irrigation or the use for water treatment. But definitely, it's better to do some remote control if you have floods, for dams and big bodies of water or in a river. This is just simple an example for your sluice gate automation. Okay, thank you for watching. This is your automation engineer, MEKALEKTRIKO.